Okay, one more thing I want to turn our attention to, and it is a very important component and one that gets ignored far too often by developers, especially new developers, and that is testing. When we write code, we want to write tests to ensure that our code actually does what it's supposed to do. Fortunately, Go makes this remarkably easy. So first of all, we need something to test. So what I'm going to do, I have a new project here with one file, main.go, and inside of that I have an empty main function, as you have to have. I'm going to create a new function. I'm going to call this function divide. And it's going to take two parameters, x and y, not very original variable names, but they'll do the trick. And they're going to be of type float32. And it's going to return one of two things. Well, actually, it's going to return two things. It's going to return a float32, which will be the result of our division, and an error, which will have an error if there is an error, or it will be nil if there is no error. So it takes two parameters and it returns two things. Now, the very first thing we need, of course, is a place to store our result. So I'll define a new variable, var, and I'll just call it result, and it's of type float32. And then we can do our division. Our division is result equals x divided by y, and then I need to return our result and an error if we have one. Now, sadly, this will never throw an error that I can catch, so I need to check for something. Now, what situations are there where dividing one float by another or one number by another will result in an error? And if you took math at all at any point in the past, you'll know that division by zero is generally frowned upon. You can't divide something by zero or you get an undefined result. So that's our error. So I can just check to say if y, which is what I'm dividing by right here, if that's equal to 0, then return an error. So I will return, and I have to return two things. So I'll return result, which is set to 0 right now because I've just initialized it, not done anything with it. And then I'll just generate my own error. And it's as simple as this, errors.new, and then I will put in my error message, cannot divide by 0. That's it. So now I can return nil down here because there is no error. So let's go through this. Here's a function called divide. I initialize a variable, type happens to be float32. I check to make sure what I'm dividing by, our divisor, y, is not 0. If it is equal to 0, return the result, which is 0, because I haven't done anything with it, and an error that I've created myself. Otherwise, if y is not equal to 0, do the division, return the result, and return nil for an error. And up here in the main function, all I have to do is call it. So I'll say result and error, which is an error. They are assigned the value of divide, and I'll just do 100 divided by 10. And then I'll check for my error. If error is not equal to nil, what should I do? I should just say, well, log println error and return. Don't do anything else. Stop at that point. Otherwise, what am I going to do? Log.println result of division is, and then my result. All right, so I can run this program, go run main.go, and it should work. Result of division is 10. Perfect. Okay. Now, what if I try to divide by 0? Let's change this to 0. Clear the screen and run it again. Cannot divide by 0. That works great. But the entire purpose of this exercise is not to learn how to divide, because you probably already know how to do that. It's to write tests. So here's how you write tests in Go. In Go, the tests themselves live right beside the code that you're trying to test. So I have one file, main.go. I'll now create another file, and it has to have a specific kind of name. And fortunately, it's pretty easy. So when I create my file, I will call it new Go file main_test.go, which means these are the tests for main.go. So it has to end with _test.go. So how do we write tests? Well, I'm going to show you two ways. One way, which is kind of manual and slow, and another way, which is way more efficient. But we'll do the easy ones first, the manual ones. To write a test in Go, it's just a function. And you have to give the function a name, and it has to start with the word test. Otherwise, it's going to get ignored. And I'm going to test divide, because I have a function called divide. So I'm going to do that. And it takes this for arguments. T is the conventional name that you're going to use for this variable, and it's a pointer to testing.t, which is a built-in package. So you'll see that it imported testing for me. Now I write my tests, and all I do is I need to get the result. In this case, I don't care what the result is. I'm going to call that function. I'm going to check for an error, and I'll divide, let's say 10.0 and 1.0. Okay? If error is not equal to nil, then what do? I throw an error, but I don't throw a standard error, I throw a testing error. T.error got an error when we should not have. So I'm checking for an error, but I'm not checking for errors in my programming code. I'm checking to see whether an error is actually thrown. So in this case, when I divide 10 by 1, that's absolutely valid, and I should not get an error. So all I'm running here is a test to say, if I divide 10 by 1, I should not get an error. If I do, then fail this test. So let's run this. And here's how you run tests in Go. Go test. That's pretty easy. And pass OK. And I can actually go do a little bit more detail. Go test-v for verbose. And it says I'm running test divide. I passed test divide. And it told me how long it took to run all the questions. I run all the tests. Now, that's one test. Let's try copying this. And I'm going to copy it and paste it and give it a new name. Test bad divide, I'll call it this time. Meaning I'm testing for bad division. And this time I'm going to say divide 10 by 0. In this case, what should happen? If error is equal to nil, if it doesn't throw an error, we say did not get an error when we should have. And again, think it through. If I divide 10 by 0, it should generate that error that we wrote in our function and return 0 and an error. So error should not be equal to nil. If error is equal to nil, then I failed the test. So we can now run the test again. Go test. And again, it should pass. And they both pass. Now, the problem here, of course, is what if I really want to test my division function thoroughly? I'm going to wind up writing one function for every one of these tests. And that's really, really inefficient. So instead, let's run what's called a table test. And we'll do this, first of all, by showing what kind of data I want to test. So right at the top of my program, right after my import statement, I'm going to write a variable, tests, and it's going to be equal to a slice of structs. Slice of structs. And inside of that, I have to define the struct. So first of all, I'm going to give my test a name, which is just a string. Then I'm going to give my name, my dividend, my first number that I'm passing, which is a float 32. Dividend, I better spell right. And then the divisor, what I'm dividing by, which is again a float 32. Is that enough? No, it's not. I want to also include what do I expect to get from the results of this division. So I'll call that expected, and it's a float 32. And finally, I'm going to put in one more variable, is an error expected. So is error, which is a Boolean, true or false, okay? Then that defines my struct. Now let's populate it with some test data. And what we're going to have is every entry in this slice will be a test that I run once. So first one I'm going to call my test is valid data. And that name can be whatever you want. But my test is testing with valid data. I'll pass in 100.0 as my first number, 10.0 as my second number, and 10.0 as the expected result. And this should not throw an error. So each of these values corresponds to each of these in order. So I'm having a test named valid data. I want to divide 100 by 10. I expect to get 10 as a result, and I expect no error. Now let's duplicate that line and call it invalid data. 100 divided by 0, and I can put 0.0 because it's a float, and the result I'm expecting is 0. And am I expecting an error? Yes, if I try to divide by 0, then I should get an error. Okay, let's just go with those two for now. These two effectively duplicate the two tests I've written already. I'll leave those there. But now I'm going to write a new function, func. I'll call it test division. And there's no T in func. Test division. And it is again of T's type testing T. And I put its parentheses there, it's curly brackets. Now I'm going to range over my tests variable. So we can know how to do that. We've already done that. For, I ignore the first one. I don't care what the index is. For each test, and I'll call it TT, which is pretty common when you're ranging over tests, equals range tests. And what do I want to do inside of that test? Well, first of all, let's just call that function. Got, what am I getting from the function? Error. If there's an error, populate that variable. Otherwise, leave it as nil and call the function divide. And I'm going to call it passing the two arguments right from this slice. So I address those by going tt.dividend, tt.divisor, and then I actually run my checks. So, first of all, what am I checking for? Well, let's check first of all to see if it should have an error. If TT is error, in other words, if this test is supposed to throw an error, then check to see if the error is nil. Because if the error is nil, I failed the test. If error is equal to nil, then fail the tests. I can put t.error, expected an error, but did not get one. So that's the first check. So our second case would be if the error is not equal, if TT is error is equal to false. So that would be an else. Else. And now I can check to see if error is not equal to nil, then I throw another error, t.error. And this one is did not expect an error, but got one. And then I can print the error out, which is error.error. I could just put error there, but you could also call the method on that, which will give it as a string. Okay, so that's our first case. And then finally, we need to check to see, did we get what we expected to get? If got is not equal to tt.expected, then throw another error, t.error, and this time I'll use error f, because I'm going to put some placeholders in there, expected %f, but got %f, and then I just populate those placeholders with expected and got. So I expected tt.expected and got. There. All right, let's run this test and see what happens. Go test. And they all passed. And if I do go test-v, go test-v, you see that it's actually running those tests. So it runs test division twice because I have two values up here. And then it runs the two manual ones. But I don't even need those anymore, so I can get rid of them because I'm already testing those. And the great thing about this is, if I want to run more tests on that, I just duplicate this and put some more values in here. So I'll put one where I expect certain results. Expected, or expect 5. And how do I get 5? Well, 50 divided by 10 should give me 5. And now I can run those tests. And it works great. Oh, wait a second here. Expected an error but did not get one. Failed test division. So, oh yeah, down here. I expect no error. False. See, that's how they work. So, clear the screen, run this again, and away it goes. If I want to put another one in there, say, expect fraction. So we're not going to do whole division this time. So we'll do -1 divided by -777. And what does that give us? Well, I already did this on a calculator. It gives us 0.00128700013. And if I type that right, this test should pass. And it passed. And that's all there is to testing. Now, one more thing about this, we can actually check our test coverage by going go test cover. And it will tell me that I actually have, in my testing course here, I have 50% of the statements are covered. And we can even get better than that. And we can do so by running this command, which I'm going to paste in. Go test dash cover profile equals coverage.out, which will spit a file up here called coverage.out. And then, if that is successful, run go tool cover HTML equals coverage out. And if I run that, it actually fires up my web browser for me and shows me what's covered in green and what's not covered in red. Now, realistically speaking, 50% test coverage is not great, but the reality is we're going to, throughout the course of this course, make our main functions as dumb as we possibly can and not bother testing them. So we're going to do as little in here as we possibly can. Instead of doing a lot within our main function, as time goes on, we'll begin to pass all of our actions off to functions, and we'll test those functions. And we just won't bother to test our main function. And we'll get pretty good course or test coverage as we go through this course. All right, that's it for testing. We'll see lots more of examples of this as we begin writing more sophisticated code.